Morning.
How's it going? How's everyone doing?
Hey, good morning, everyone. Cool. Let's give it a few minutes for folks to sort of trickle in here. I guess while we're waiting, for some folks to join, maybe we can do just a quick round of introductions, just so folks know kind of who's reading the paper and what our backgrounds are. So I can go first. My name is Aman. I'm a product manager here at Arise, working very closely actually with all the folks on this call on our product roadmap, and then working with the engineering team to sort of make things happen. Background is technical, working at machine learning platforms and at companies like Cruise and at Spotify. So yeah, super excited to dive into this pretty awesome paper. I'm joined by Adam, Michael, and Jason. Jason, maybe would you like to go next?
Sure. Co-founder here at Arise. I'm Jason. Great to see everyone. Go ahead, Adam.
Cool. My name is Adam. I'm managing the full stack team here at Arise, so helping maintain the platform and build out new features. And I started off as a journalist actually, but for the last 10 years I've been working in tech.
Hey, I'm Michael. I'm the CTO here at Arise. Helped start the company with Jason and been working on distributed systems, machine learning systems for a while now. I'm on, I can't hear you.
Yeah. So just in case, hopefully you're a repeat attendee, but in case this is your first time, what we're going to be doing is basically diving into a paper, sort of dissecting it in our understanding of what the authors are intending to convey, taking apart some of the architectures and the data that goes into some of the models that we're going to be talking about, and then looking at some like real world applications where would some of these papers be applied, where might they fall apart, really with the intention for all of us to just sort of learn as we go. So definitely meant to be conversational, and think of it as really like we're just all in a group just sort of reading this paper. So I believe the paper link will be shared out, so you can follow along as well on your own screens, but I'll go ahead and share my screen. And if you have any questions, just feel free to pop them in the chat and we can sort of take them live as well. Cool. So today what we're going to be reading about is kind of a fancy title, I think: precise zero-shot dense retrieval without relevance labels, that kind of have been colloquially known as HyDE. So this is a pretty recent paper. So hypothetical document embeddings. Adam, maybe do you want to give us just a quick overview of what this means exactly for someone who might not have much context on what this is?
Sure. So just to start with, dense retrieval, the idea here is that you can use an LLM to perhaps, the LLM may not be educated on the actual question you're asking it, but given a corpus of documents that you've embedded, you can actually do some kind of search in order to retrieve the right document, include it in the context, and get a much more accurate answer to the question that you pose it. So zero shot here means without any kind of fine tuning or training, you just give the LLM a question. It does its best to embed that question and find the most similar document for it and come back with its best guess of the answer. The challenges here are often that without this kind of fine tuning, it doesn't always know, it doesn't always do a great job of retrieving the right document with the right context. And so, the solution to this is there's a lot of different strategies that people have used to give it the right context to make sure it retrieves the right context, whether that's adding in another step to help rank the documents after they've been retrieved, or perhaps fine tuning the model or the embedding vector, the embedding tool that it uses to create the space and make sure that they're all sitting in the correct space together. But this poses a new option. Basically, the idea here is instead of just the very high level 10,000 foot view is instead of just encoding the query itself, perhaps you can add a different step. And that step would be asking an LLM, in this case, an instructed GPT LLM, to generate a hypothetical document that answers the question. Now, it's not expecting it to generate a document that actually looks like it answers the question or has correct information in it. It's more about creating this kind of structure. And then instead of embedding the query, you could then embed this document, which would give you a higher probability of getting a correct relevant document that would look like it would answer the question. And so it tries to basically go into how effective is this strategy. And the paper believes, or the paper, at least some of the documentation shows that it is more effective than just zero-shot retrieval without any kind of fine-tuning or without any kind of relevance labels in general. But there are definitely some caveats that they are pretty good about explaining the way through.
Awesome. Thanks for that overview. Cool. I figure, like, you know, just like at a high level, you know, there's some interesting value here where when we talked about RAG a couple weeks back, and retrieval augmented generation, sort of the seminal piece on context retrieval for, you know, augmenting an LLM, an LLM's response. What's kind of interesting is there's a ton of development happening in the retrieval space, and this seems like, you know, kind of makes sense. What if we threw an LLM at the retrieval component? I guess, Michael, what could you maybe talk about, like, you know, if you're building one of these systems, like, why do you need relevance labels? Like, what is the value of like the zero-shot dense retrieval? Like, what are those, like, breaking down the, you know, what those terms are in the architecture, and where HyDE can help?
Well, so dense retrieval is that process of search via semantic embedding. Relevance labels help you fit the encoders that define that problem. So a little bit later on, they have that equation number 1 that basically defines the dense retrieval process as a maximum inner product search of the two embeddings, the embedding of the query vector or the embedding of the query and the embedding of the various documents. So in order to fit good encoders to minimize that maximum inner product search, or to train a system where the inner product of said vectors represents relevance, you need relevance to fit those encoders. And so they state as really like the problem of dense retrieval, and the zero-shot case of dense retrieval, as learning those two vectors without, or those two encoders without any relevance labels. And basically this technique is a way of sidestepping that problem by saying, well, we're not actually going to learn these two encoders simultaneously. We're going to have a single encoder that's, you know, trained to do document to document similarity, which is there are well-known techniques for doing this without supervision, and just keep the whole problem in the document to document search realm. And so it's kind of an interesting way of sidestepping the problem, which I find is often really successful. Like if you can figure out a way to take a hard problem and make it a different problem, that tends to work out well if you know an answer to that other problem.
Yeah, it feels less like necessarily, it's the paper isn't so much about like the lack of relevance labels as much as like, here's like a synthetic generation for, you know, what could be like in place of a relevance label to do this.
Well, that's what they say that the instruct GPT output is meant to capture. Like to Adam's comment earlier, we don't expect it to be factually correct. They actually expect that it will contain factual inaccuracies, but that it would capture the relevance. And we can talk more about this later, but that's where I have some thoughts about the edge cases of this, and places where in their comparisons they show it start to perform less well. Yeah, that the output is capturing some relevant structure that you would expect to find in an answer, maybe populated with incorrect details. And then they have the metaphor of the embedding of that document as a kind of compression, where you lose those inaccuracies.
Yeah,
I wonder how much that is a good way of thinking about it.
And I wanted to add, like, there's kind of something. It's funny. I was talking to someone recently, and it's almost like all the LLM app people have discovered search and retrieval, when all these other people have been working on search and retrieval for decades. And but what's interesting is like there's kind of a sparse, like when we say dense retrieval, there's a bunch of sparse techniques that have been around a while, and lots of different variations of those, TF-IDF, and then indexes for word specific stuff on large, millions and millions of plus indexes. And contrast that with like dense, where you're kind of compressing the information and what you're looking for into an embedding or vector representing kind of all or important parts of the information of the document versus like specific words. This kind of the dense versus sparse worlds that worth noting as we kind of dive into this. This is trying to improve and really improve the dense approach, which is embedding and vector based.
Jason, what's the difference between like the dense and sparse retrieval? I think that's an interesting note to touch on. They reference that here as well, like, you know, extensively studied after the emergence of pre-trained transformer language models. Like why, you know, what's the difference, I guess, between dense and sparse approach to retrieval?
I mean, I think, I would say the thing that's come about is just once you train a model on a lot of data, a large model, you have the potential to have this, I mean, in old form, you call it transfer learning, but like you then don't need to potentially, you can embed stuff, you can use it in areas to create embeddings that represent a lot of data. So I think I think transformers empower you to create embeddings on lots of data. I think that's the big.
And in RAG, that was like parametric, non-parametric memory, like call it parametric memory, whatever's encoded in the transformers parameters, basically all those embeddings that are used to generate the architecture.
Correct. So you're pulling out an embedding at the last layer that represents structure in the data in some way that's captured into a vector in the space. Compare that to a more hand-drawn TF-IDF, sparse approach for searching stuff. It's word-based. It's very different type of approach versus like understanding the doc itself.
Yeah. So interesting. So let's take that thought. So instead of having to understand the doc, this HyDE sort of instruct GPT is like taking in some question, how long does it take to remove a wisdom tooth? And then writing basically you wrap that in like a prompt wrap that query in a prompt, and then ask the LLM to generate some piece of text that can then be used to do the retrieval, to do the lookup. So what's interesting is like this, as Michael touched on earlier, this doesn't have to be like factually correct, but it gives you a sort of a better lookup than like, like you could have like in your knowledge base hypothetically, if you're doing context retrieval, maybe you're working at like a dental company, you have a lot of documentation about teeth and wisdom teeth, but this one is asking specifically about remove, and maybe there's some more information created from, like the time it takes or the type of tooth or the process that can then be used as, as a quote unquote relevance label when coming time for that retrieval. So I think that's like, I thought that was a pretty good real example. And Michael, you had one yesterday of like, was it like baking a lemon cake or something like that?
Yeah, that was on my mind. I had been baking over the weekend. But yeah, I mean, you bring up the case of like searching within your documentation. I think it's interesting the way that they cite some of the performance degradations as the corpus gets more narrow. And I wonder how much of that is because the relevance that you're capable of capturing in the parametric memory of instruct GPT is high level and structural, and that as you get more into the specificities of a search, you're not just looking up you're not looking for a document in the corpus of everything. You're looking for a specific document in a corpus of documents that are very similar to it. That this approach is going to begin to fail because the items that make it relevant are in that long tail and are going to be present in the factual details, not the structural makeup of the document.
Right. So let me
for a recipe in the corpus of everything, HyDE giving you an incorrect recipe that is structurally a recipe still is probably going to help you more than looking for a good recipe in a corpus of recipes where the structure is no longer indicative of high relevance, I guess.
So let's build off of that and say like, basically the alternative that they're comparing to is a fine-tuned dense encoder. Basically means if you had your model trained on all of the data that you have that's structured a certain way, HTML markup, recipes that follow a certain format, a certain language, this is a way to work around or operate around that. I guess Jason or Adam, like, what are your thoughts on like the importance of the structure of the text that you're feeding in? Like, where does this, like, how the docs are formatted, like, you know, is that basically where this starts to become useful, is just in capturing signal in the formatting and the structure of the text?
Yeah, it's funny because I think, you know, if you go back up to that, the first figure, you do have like a hidden prompt engineering problem in here, which is how can I correctly ask for, like, I'm asking for a scientific paper passage, or I'm asking for something in Korean, or, you know, if you were doing docs, like, can you write me a technical document in Markdown that might actually be able to correctly structure the document? I think you do get around one of the issues, which is you know, getting a question to pull out an answer to it, which are just very structurally different. You might not be able to get that kind of relevance between the two of them. So it does sidestep one problem, but it's not, I think Michael is correct in saying that, like, there's probably a limit to this. Like, at the end of the day, all technical documents may not look exactly alike, but have a pretty high structural similarity. So if you're trying to do a search across, you know, for instance, there's an Arise, there's a bot that can look through the Arise docs. And if you're looking for a very specific question, a lot of those docs might be structured very similarly, have the same markdown structure and, you know, high level sections that kind of similarly look. And so there might be some, you might not have as high of a success rate trying to generate that kind of document and make sure that you're getting the right one out of all of these relevance, out of all of the different, you know, options.
Right. A key manual would start to look the same, even if they're different.
Exactly.
I think the point I think they were making too is that the thing they call the contriver, which, by the way, like I being not like the deepest search and retrieval person, I'm like, what's this contriver thing? As far as it looks to me, it's an encoder that's and the magic of this paper is that it uses that contriver encoder, which is, think of it as an embedder to those of you in the LLM app space, but basically it takes the document, creates an embedding, maps to an embedding, a latent space. That contriver, in the example it gave in the beginning, they have a comparative paper that fine tunes it or supervises it to a search and retrieval task. In this paper, they don't do that. Like, it's unsupervised. It's just a pure embedding thing, not done. Like, you could fine tune it for the Marco task here, or the beer task if you wanted. But what they're saying is, let's not, like, it's a real pain in the butt to have to, like, fine tune something. It's, you know, you're fine tuning for every use case. In this case, you don't have to do that. Part of my look was like, well, could you just swap out the contriver for, you know, the added to embeddings model? Like I wish I was reading through wondering that myself. But that feels like the big idea there that we're talking about. Like, you know, by doing a larger training run on a large set of data and creating a large unsupervised pre-trained model, or semi-large, you get around those, you know, the issues with a small, a small tiny model. So I think I felt like the contriver was kind of one area of interest. The other one was just like this section here, which is like the generation of all the documents. I'm not sure what it looks like. They're generating multiple documents here in addition.
They sample the instruct GPT to get several hypothetical documents. They embed them with contriver, and then they take the average. And I thought it was interesting, they also add into that average calculation the embedding of the query.
I saw that. So most of the LLM apps people, the LLMops, I'll say LLMops people, are just doing the query, right? Like, so one of my questions on this was like, well, what if you just embedded the query? What would those results be? Which is what most people are doing right now, versus the full doc.
That's one of the comparisons that they run, right, Amon?
Yeah, I'm trying to find it actually.
So I think that's where you end up wanting to fit a document encoder and a query encoder, but you don't have you've assumed away your relevance labels to fit that. So you embed a query, and that query is going to look nothing like the document that answers it. And you take an inner product search, and you're likely to find documents that look like other questions rather than.
That's a good point. That's a good point. It's interesting.
That's a question actually that someone can ask. How does offloading relevance modeling from representation learning model to an NLG model impact the effectiveness of this approach?
So the question there is like with this generative approach, which is essentially what they've taken. How is this, how does this make better or worse like the final results relative to a more kind of maybe representation learning model NLG?
Yeah, like basically just offloading the relevance, like the actual like relevance calculation, and using that in the equation, and just using this like kind of proxy for relevance.
You're no longer needing to learn two representations of things. They don't have to learn a representation of the query where inner product encodes relevance with a representation of the document. That's I mean, we're on equation 5 now, but if you go up to equation 1, they say that the hard thing is learning these two representations simultaneously. So learning an encoding of the query and an encoding of the documents such that the inner product represents relevance. And so they say we're not going to do it. But I imagine if you have relevance labels and a wide corpus of labeled relevance data with question and answer pairs, you'll do better if you fit two representations. I just think their point is that this is more real world. Like in general, you are not going to have access to such a labeled set of relevance data. And so most sidestep the problem.
And so many of the practical examples that we're seeing of people trying to, use this context retrieval and to create a document, like a product that people will actually use, are using fairly small corpuses. So you may not be able to generate the kind of relevance labels that you might want to see to have the fine-tuned encoding that would, actually be able to create a similarity between the question and the document. And so it's to me, this is a very practical approach. And that's actually how when I first saw this paper, it was referenced by someone who is building LLM apps for the process of retrieving over a small document corpus. And there were several people who agreed that this is a fairly effective way to do it, given that you don't have the ability to train, or you don't have the corpus of information to train on. You can get pretty close to a fine-tuned performance by just doing this process, which is in a lot of ways may be less resource intensive than some of the ranking that I've seen on the other end of the spectrum, where you like grab a bunch of documents and then rank them relevant to the question itself.
Yeah, and I'll jump ahead a bit to the conclusion, but they do actually talk about the trade-offs here, which is the concept of relevance in HyDE is captured by the NLG model. We demonstrate in many cases HyDE can be as effective as dense retrievers that learn to model numerical relevance. But the idea is they're not actually saying that, a weak retriever will suffice as the NLG models rapidly become stronger. They're like, this actually works for now if you're just getting started, to sort of jump that step of having to train that retriever or train that embedding generator. But, it's not really going to solve your problem the whole way, most likely.
Michael, do they have the question? Do you know in here, do they have just the pure question embedded?
I didn't look at the corpus of documents that they included for search. I'm sure they make it available, but I haven't had a chance to check.
The ablation I would like to see, the thing I would like to see is the thing people are doing today, which is embed your query and just use that
with no additional fine tuning. Use the same document to document encoder. So you assume the same document encoder as query encoder, encode the query directly, and do inner product search on that.
Because they're doing it, they're mixing the query in.
They do,
but they don't. I didn't see. Maybe they have.
It's not even a weighted average. It's a
it's
a straight average. Aman, you had that highlighted at the end of relevance being a statistical artifact. I think it's sort of an imperfect analogy to try to map these techniques onto human processes. But it's been interesting to do in the Minecraft Voyager paper, and here it's reminiscent to me of skimming a set of documents from a Google search, and you know, you have an instinctive sense of what is relevant before even really digging into the details. You know what a relevant document's going to look like, and you feel it when you see it if you've done a lot of searches. And this feels like a way of modeling that intuition in search. You have an idea of the shape of what you're looking for. You don't know the answers that it will contain yet, but you can tell the document when you see it.
Yeah, I mean, we're running some experiments or like taking a look, and some folks we've talked to is like, what's interesting is like the queries that they have here are like, you know, actual questions. How long does it take? How long is it? But like oftentimes if you're searching, or even like how you type into Google, I think that how people interact with search now is like different, right? So I mean, if you're talking to an LLM versus to just like, you know, expecting to search over an entire corpus, like even how you generate that initial query and what you're supposed to do with that, what this LLM, the instruct GPT is supposed to do with it, is so interesting to me as an interaction. Because, you know, you could say, well, why don't you summarize this first? Why don't you generate some intermediate generated step and then create a generated document off of that? Like, you know, interpret what the customer or what the user is asking, break that down, provide more structure, and then feed that in. And maybe that gives you an even better, higher quality generated document. And then it starts to look even more realistic, you know? So I don't know. It's interesting that we're like moving further and further up in the zero shot world by sort of breaking down, trying to decompose the task of retrieval into like LLM steps in a way.
In some way, it makes a lot of sense as well, because, you know, that's what the way that it would look for it, like you're generating the document using the kind of parametric memory that it has over what this document should look like. So that kind of its own intuition of what would be relevant is somewhat encoded in a hypothetical document. Yeah. And it's not perfect, right? Like, you know, if you ask how long it takes to remove a wisdom tooth, you can say it takes between 30 minutes and 2 hours. And then when it says it takes 20 minutes, that relevant search might come through. But I am curious to see whether it, like, the less it would have kind of like straight answers to something, where it's more like, okay, this is actually a very large step-by-step process to construct this API query. Like maybe it wouldn't have the type of relevance encoded into it to be able to generate a relevant hypothetical document. And that did bear out a little bit in some of the results.
It is worth noting, by the way, that LangChain does have a HyDE version here. So what the contriver is add two embeddings from OpenAI. So you can actually compare, you know, an approach pretty easily using LangChain, which would be, you know, interesting to see. So there is a HyDE retriever if you want to, you know, if you happen to have LangChain in production and you're doing, you know, query retrieval, there's an option to swap this out and test.
Does it say what it uses, or can you swap out which model it uses to generate the hypothetical document?
I think the embedding store, the one you decide for embeddings is what, or the yeah. So there's the embeddings one, which is the contriver, and then I think it's the OpenAI is probably the. Yeah,
and you can swap out the top.
Yeah.
Uses by default, right? So.
And the LLM is going to be your generator one.
Yeah, because one of the more interesting pieces from the results table was that the better the LLM you use to generate the hypothetical document, it actually impacted performance pretty heavily. So this could also be one of those things where, like, as LLMs continue to get better, this method might also continue to improve as well.
Yep, it's also worth noting that all the, you know, from traditional from the traditional space, there's these score, like there's Marco data set, there's the beer score, there's a lot of stuff where the traditional side has done a lot of testing, which I feel like is, you know, not brought up much in the current space. It's, a lot of, and I think a lot of people are just trying stuff out and seeing if they feel like it works, and kind of filling that breakage before trying to go do a rigorous test on things. But I think there's a question in my head of like, should you even use this HyDE, or should you use, how good is it relative to the basic, query embeddings people are doing? It'd be good to get some both anecdotal and more quantitative results too.
Yeah,
I would be interested in a test across a more diverse set of document corpuses. My intuition is that the success of this technique is going to depend significantly on what you're looking for and the corpus you're looking for it within.
We got a question from oh, sorry to cut you off, Michael.
No, go ahead.
We got a question that's somewhat related, actually, which is, I'm curious if this approach is worth experimenting. Instead of giving supervision as pairs of query and documents, we maybe are able to just give just the set of documents and influence the generated document given a query to be closer to the set of documents in the search space. So yeah, so that's basically, what it, kind of just running experiments in the space and seeing which one works for your application, depending on how dense how your query embeddings already look like, or your document embeddings already look like, how dense that space is.
I did want to give a plug for, we do have a Pinecone, LangChain, Arise workshop tomorrow. So maybe we can drop the asks of the LangChain team if they tested HyDE or whatever. But anyone who's interested in like a little bit more of search and retrieval debugging and troubleshooting, let me give just a little plug for that with the team tomorrow.
Yeah, and we'll actually be building a system from scratch. So if you're interested in like getting started, you don't know where to start, we'll have a notebook that we'll be sharing out that you can actually run through with us in that. And we'll actually build a system, test it out, and then actually query over it. Cool. Any more sort of takeaways we want to touch on here? I think like, one interesting point, actually, Michael, you brought up yesterday was, when we were talking about this, was you kind of view this as like initialization on algorithms. Like why, like, let's take a, like if we're running an experiment, you want to put the bounds on this. Like alternatively, when you feed in this, when you're feeding in a query, the instruct GPT doesn't use the query at all. And instead it's just like generate a random document. Why is this better than just generating a random document? Why is it better than random? How does this
Sure, it's better than a random document. I mean, my connection to an initialization process is I think sort of related to Jason's thought of, if you're going to assume I don't have information to train two encoders to represent relevance in the inner product calculation, I just have my pre-trained contriver that can represent document to document similarity. How much better is this than just taking the encoding of my query? And that in my mind is the like random initialization. Just encode your query, and then if we're going to assume, okay, I can't fit a query encoder and just encode my query is not performing so well, can I initialize the process by which eventually I hope to have relevance and fit a better representational model? But can I in the meantime kind of initialize my problem and start my search from a guess of at least what a document might be shaped like, if not what it contains?
Are there any other retrievers that seem interesting for folks as well? Like this type of retriever mechanism, like any other retrievers that stood out?
Yeah, so I think there's a question, I think Shobit put a question in there, Aman, if you want to.
Yeah, we kind of talked about it, but it was, given was supervised as, pairs of query and documents basically having those relevance labels. Why is this? Why would you use this approach over that? And then like maybe what are some other retrieval approaches?
Yeah,
I talk about that. Oh, go ahead. Go ahead, Jason.
I was going to also mention that I have heard from some folks like and maybe Shobit was hinting on this, but like that there are systems already built that people have that are like Elasticsearch or something. Like you possibly could have some relevant documents and then maybe generate and get yourself closer to it. So there might be ways of using systems already in place versus the pure generative approach, or using those in in conjunction with, which might have been the hint there.
Yeah, they do talk towards the end of the paper around this being like a good intermediate step while you would fine tune. Like once you have this in production for a while and you get a large corpus of data around questions, the correct relevant document, what the correct answer is, you can continue to fine tune this process at every different step, whether you fine tune an encoder for queries and an encoder for documents separately, or perhaps something that would be interesting is just encoding the one unified encoder for both of them so that you get more relevant answers. So like it would be like, I don't think they're seeing this as this kind of, this is the one process and this is what's going to work for every stage of maturity, but as a bootstrapping mechanism to get you to the point where you can fine tune things, it might be a very effective strategy. And I do think it's interesting to think about what, a comparison I would like to see is whether you could, if the performance between different levels of LLM for generating the document is so great, what would the performance be for, we're not fine tuning the encoders, but we're instead fine tuning instruct GPT on the existing corpus of documents? Would it get better at generating hypothetical documents that would then in turn provide a stronger relevance mechanism for grabbing the right document? So I think there's a lot of options in mixing and matching that we're probably going to see in the very near future with this.
Yeah. I can't help but think also the number of LLM calls where we kind of like I think earlier, like we were doing a search and retrieval with Llama Index the other week, and we're like, oh, maybe you should have an eval after your retrieval, but now we're gonna call out and do this generation before the retrieval. I mean, I hope these companies are making these fast and cheap so that this and I know they are, but there's a lot of calls to to these and just to get an answer.
Yeah, you do wonder at what point the cost benefit, you just train it to work correctly, or even apply a sparse approach that is not as sophisticated. But
yeah, I would say, like, actually just building off of that, like the authors do say, actually, Jason, because it's relevant to the Llama Index example you gave. In Llama Index, you can re-rank the, retrieved documents to generate the response or to feed into the context for the LLM. They basically say just compare it to that. And if you don't have relevance labels, this is a good alternative to having those relevance labels or generating those relevance labels. So yeah, I think maybe it would be interesting to run some experiments, see how it works with like re-ranking over a density set versus generating this hypothetical document.
Yeah. So if anyone's listening and in academia, there's probably there's probably some research work on which retrieval methods should you be using. I don't know. Cool.
this is fun.
Yeah, this was a good one. I feel like next week I think we're doing one on another model architecture. I think it's Glora, so building off of Laura. So should be pretty interesting. I feel like the architectures that come out every week or every few weeks are really feel like leaps forward. Pretty exciting time to be in the space. So definitely join us next week for that. And yeah, we have this Pinecone LangChain workshop tomorrow. It's online, it's free. Just register. Feel free to register in the link that Maggie posted. And yeah, we'd love to see you there. Get your feedback.
Someone was raising their hand, maybe. Chris?
Oh,
I don't know if that's what they can do here.
I think you have to drop a question.
Okay.
I saw it, but it cleared.
Okay.
Oh wait, 10:35, 10:46. Yeah. Okay.
Cool. All right. Thanks everyone.
Thank you, everybody.
Bye.